Welcome to the VMware Cloud on AWS Deep Dive session. My name is Jin Jiang. I'm with the EC2 product management team. Super thrilled to see a room full of all of you here helping us to learn a little bit more on what you need and how to best serve your need.
Hi everyone, my name is Andy Reedy. I lead the Partner Solutions Architecture team for VMware Cloud on AWS at AWS. So my team works with VMware's product and engineering teams on actually designing and building VMware Cloud on AWS. We also work with customers and partners who are interested in learning more about VMware Cloud on AWS and how it can be leveraged in their environment to help them solve their problems and accomplish their goals. So to level set, this is we're going to dive into some technical details in this session, but one of the things we always like to start off with is just level setting on what's the problem we're trying to solve. What does VMware Cloud and AWS do? What's the real value proposition for it? And there's a lot, but fundamentally, if you kind of boil things up at the highest level, whenever you move to the cloud, or if you've gone through a cloud migration, it's not as easy as just clicking a button and moving from your on-prem environment into a cloud environment. There's a replatforming effort. There's a conversion that takes place. There's a lot of effort that goes into actually making this migration possible. And one of the things we started looking at with VMware Cloud and AWS is how can we take the ability to right-click and migrate a VM on-prem, and how can we move that or apply that into a cloud environment? And if you think about it, the way we build and run applications in the cloud is drastically different than the way we do that on-prem. In an on-prem environment, there's a lot of applications that just expect the infrastructure to take care of the resiliency, to abstract that level of redundancy and resiliency from the application. Whereas in the cloud environment, it's a little bit different approach. In the cloud environment, we provide logical constructs so that you can make your application aware or have them take advantage of these logical constructs, things like availability zones and regions and autoscaling. We provide the constructs so that your applications can take advantage of that. But what happens when you move an on-premises application into the cloud, and that application is maybe a legacy application or maybe one that was never designed to take advantage of these constructs? A common example I run into is I have this application. If I were to try to change its IP address, it would just wig out. There's no way I could do that. But how do I take that application and move it into a cloud and have it be able to actually run in multiple availability zones or survive a change between AZs? So that's one example, but there's a lot of legacy applications or a lot of applications in general that just don't have the ability or were never designed to take advantage of these cloud constructs. How do I move those applications into the cloud? How do I run them in the cloud? Another example is the actual skill set and tooling of the people. Folks who've worked on VMware for a number of years are very good at running vSphere-based environments. They're very knowledgeable in those environments. But it's a drastically different world going from a vSphere environment into an AWS environment. There's different constructs, different capabilities, different things that exist. And so being able to actually apply the knowledge that folks have gained over a long period of time and have that still be relevant in a cloud world is another example. Likewise, not having to go through that re-platforming exercise. When I move to the cloud, I don't want to have to actually re-platform and move into a different system and have to change my monitoring tools, have to change my scripting, my backup solutions. I don't want to have to change all this. So you can just see this is all adding up, right? When you move from on-prem into the cloud, it's not a simple right-click and migrate. And this is one of the things we really wanted to tackle with VMware Cloud and AWS is how can we take the familiar vSphere interface, how can we take the familiar vSphere platform and have you be able to run that in the cloud, have it be able to protect the applications and run the applications in the same way you do on-prem, but also to get that elasticity and scalability in a cloud environment.
And of course, with audience here, we've made the assumption that you're interested in these technology and these kind of challenges, but it would still be good to validate. So right after lunch, if I can have a show of hands, how many of you guys here work with VMware technology on a regular basis? Almost all of them. Thank you. And how many of you also play with AWS technology on a regular basis? Great. And how many of you connect with some of the challenges Andy has just talked about or the desire? Raise your hand if you're thinking about, I don't want to refactor, I want to keep a lot of the tools going, and I want to be able to gain the agility. Excellent. So when VMware and AWS announced this partnership working together, we had exactly these kind of needs in mind. And we also recognize in order to make them truly work as smooth as possible from a customer perspective, we cannot just simply grab one product and say, now we're going to jointly go to market together, and we're going to do some sort of certification. We really have to look deep underneath the hood to figure out how to best enable that. And therefore, VMware Cloud on AWS is a deeply co-engineered product that has taken in a lot of the thoughts and a lot of the challenges we've just discussed here, right? In how to leverage the best of both worlds, but also minimize the number of the changes customers have to go through. And I'm happy to report that we've got a pretty fast pace of innovation so far. If many of you recall, we initially announced the partnership back in 2016. Last year, right around this time, is when we had our first version released and becoming generally available. Now that a year into this new product journey, we not only have the product available as of today in 10 AWS regions now, but also, we're talking about more than 14 releases has been rolled out with, 200 plus features. So it's fairly significant amount of capacity that's currently in the product. We also have significant amount of learning from our customers about how they use them, what kind of challenge that helps to address in their business environment. And from here, we think it's important for us to take you through on both sides so you can go back and forth between technology and business need and understand how to apply them. Before we go there, however, I'm going to let Andy first set the stage for us for some of the foundational knowledge or the fundamentals of this technology stack.
So one of the things we're going to really talk about is first defining some of the terms. A software-defined data center. So if you've worked with VMware technologies for any period of time, you've probably heard this term. It's been very popular in the market. I think the last few years it's been kind of the key thing that VMware has discussed. So what is a software-defined data center? Why do we care about this? So a software-defined data center at its core is essentially the virtualization of all of the components that you would have in a physical data center. So the compute, the storage, the networking, the management plane, the virtualization of all of these things. So a software-defined data center with VMware Cloud is essentially delivered as a service. So VMware Cloud and AWS at its core is vSphere delivered as a service. I can click a button, I can have a fully functional VMware environment deployed, and I can have it ready to run workloads in under 2 hours. So I can go from 0 to workload ready in roughly about 90 minutes. Depending on your cluster size, mileage may vary, that type of thing. But if you think about it, that's a drastic change from what we were able to do on-prem. I know in my past, at least, I've spent weeks building and deploying environments. I'm sure you guys have as well. It is not a trivial task to get a new environment stood up. You're purchase ordering, getting hardware received, getting an asset tag, put into racks, powered, burned in, installing the software, installing the hypervisor. If you're using vSAN, installing that, and if you're using NSX, installing that. There's compatibility guides to make sure you're running the right versions and everything works together. This level of effort is measured in weeks or months. If you can do it in a shorter period of time, please come talk to me. I'd like to chat with you further about your magic abilities. But this is something that typically takes a good period of time. So think about all that work that's being done, and now you log into a console or you make an API call, and you have a fully functional vSphere environment running in 90 minutes. Game changer, right? This is a massive difference from what you're accustomed to in an on-prem environment. So I have this vSphere as a service. Cool, I can click a button, I can deploy a cluster, that's great. One other thing that really sets this apart is this is a managed service from VMware. So it's a managed cloud service. VMware is actually responsible for patching, updating, and upgrading this environment. So I was talking with a customer the other day, and they said they had 2 people dedicated full time to actually just running through all of their virtualization environment and doing updates. And as soon as they finished, they basically started over, and we were applying the next patches. And if it was a hot fix, well, that was going to be a whole different story. But there are resources dedicated just to doing nothing but patching and updating and upgrading these environments. That's a lot of undifferentiated heavy lifting. I asked a group of customers one time and said, hey, has anybody in here ever won an award or have any trophies in their lobby for having the best managed vSphere environment? No, nobody does, right? That's undifferentiated heavy lifting. That's stuff you have to do in order to run your environment, but it's not really going to make a needle-moving change in your business. It's just something that you have to do. So in this case, with VMware Cloud and AWS, we can remove that undifferentiated heavy lifting. Let's let VMware actually patch, update, and upgrade this environment. They're going to be responsible for it. We can focus on running our workloads. Interesting piece here also is there's auto host remediation. So since VMware is managing this environment, if there's a failure, if a host were to go into a degraded state or a host actually fail, VMware will respond to that. So you as a customer are not responsible for getting paged in the middle of the night and having to deal with a host failure. A host goes into a degraded state. Cool thing here, since this is a cloud and we have elastic capability, VMware automatically adds a new host into the cluster. They put the existing host, if it's in a degraded state, they'll put it into maintenance mode, and they'll evacuate the VMs off of that, drain the VM, and eventually pull it from the cluster. So this has a lot of implications from a capacity management standpoint. If I can click a button and I can add a new host to a cluster in 10 to 12 minutes, and I can have a replacement host added to the cluster at the time a host fails, do I really need to leave that much excess capacity in my cluster to be able to survive these failures or to be able to grow? If you look at traditional environments today, most people are running their vSphere clusters at a 40% utilization rate, maybe 50% if they're really pushing it. But they have to leave that excess capacity. They have to run at these very conservative amounts so they can survive those failures. If you have a failure, you don't want your workloads to feel that failure, right? If somebody comes in and they say, hey, I need another 10 VMs, you don't want to have to respond to them saying, great, we're going to have to buy another blade or buy another server. That's going to be 3 to 5 weeks before we can get that for you. So everybody always leaves a lot of slack capacity in their cluster. They leave that excess capacity so they can handle situations like that. Think about how that changes your capacity planning if now it's automatically replaced, you can click a button and add. Maybe instead of 40 or 50% utilization, maybe now you can crank it up to 60%, 65%. You can really push these hosts a lot harder than you would in an on-prem environment. Then there's the elasticity piece. I mentioned being able to click a button and add a host. One cool thing here is you can go from, say, 3 hosts all the way up to 10 hosts with the click of a button. So if you have cyclical workloads or you have a time of year where things are very busy, you can actually add those hosts on demand, pay for them hourly, use them when you need them, and then get rid of them when you don't. Another good example here is if you have a development project, maybe you want to do an experiment with your dev teams, and they want to try something out, but they're not sure if it's going to work. Do you really want to invest $300,000 worth of CapEx to build an environment for an experiment that may not work? It's not like you can send that equipment back when you no longer need it. In this case, you could click a button, deploy a cluster, do your experiment, run your workloads. If that experiment fails or you decide you no longer need it, you can shut it down. If it succeeds and you want to scale that thing up, cool, click the button, scale, add more hosts to the cluster. But you really have this ability to scale up and down based on what your needs actually are in the environment. And speaking of that scaling, I want to mention the consumption model for this. So there's really 3 ways to consume VMware Cloud on AWS. There's hourly on demand. So this is a case where you pay for a host on an hourly basis. There is 1-year subscription, so you can actually subscribe and get a discounted rate if you commit to that host for a full year. And then there's a 3-year subscription. So if you know, hey, this is a host I'm going to have for a good period of time, you can do a 3-year subscription. And you can mix and match these. So you could say, look, a 3-host cluster is my minimum watermark. I know I'm always going to need 3 hosts in my environment. I will do a 3-year subscription on those 3 hosts. But in fourth quarter, whenever it's a busy time of year, I can actually go to 6 hosts, and I'm going to pay for those additional 3 on an on-demand basis hourly. So you really can change the way that you consume these hosts. It's no longer long-term CapEx having to depreciate those off over a long period of time. So let's take a look at the SCDC on the left here. So you have ESXi at the bottom. ESXi in this case is running on dedicated bare metal instances. So if you guys remember last year at reInvent, we announced the i3 metal instances. These are dedicated bare metal instances. VMware was a big part of, we were working with them in a joint engineering effort to actually build these instances, so they were the first partner to actually launch a solution built on i3 metal. We had a great time working with them on this and getting the i3 metal instances out the door. So they are taking i3 metal instances, running ESXi directly on top of that, and then delivering that to you as a service. So they're taking care of the hypervisor itself, and all of those components are run by them. From a vSAN perspective, the i3 metal instances have local flash NVMe storage. So rather than using external storage on the i3s, they're taking that local instance storage, and they're using vSAN to actually aggregate that together into a distributed data store. So if you've ever used AWS, and people always talk about instance storage being really high performant, but they say, hey, don't use it for anything that you need to keep, because if that host dies, the instance storage goes away. And then when I tell people that VMware Cloud on AWS is using instance storage on i3, everybody kind of gives me this wide-eyed look like, are you serious? Wait a minute, if that host dies, you're going to lose the storage. The reason this works is because of VMware's vSAN technology. They take and actually replicate that data across all the hosts in the cluster. They create a distributed data store so that if a host fails from the environment, data is not lost. That data still exists on other hosts. So they're aggregating the local storage together with i3s. What this means is if you need more storage, you just add an additional host to the environment. And so you can scale storage and compute linearly in this case. So with NSX, this is also really interesting. VMware has network and security technology called NSX. NSX is basically building an overlay network on top of native AWS VPC. So VMware is running this inside of a VPC. They're running this on subnets, but you as a customer will never see these subnets. You'll never see the underlying VPC. VMware creates logical networks, or gives you the ability to create logical networks, and they're essentially encapsulating that traffic between the hosts themselves. So if you're familiar with NSX, you've probably heard of VTEPs and VXLAN, or even Geneve with the newer NSXT. But they are encapsulating that traffic between hosts and creating an overlay network. So this is not running, your VMs are not connected directly to an AWS VPC subnet. So that's one important piece to know. Big thing here on the vSphere side is this is vSphere. If you log into vCenter, we'll look at that here in just a bit, but if you log into vCenter with VMware Cloud on AWS, you are going to be completely underwhelmed. It is vCenter. It's the same thing you've always seen. It's very comfortable, very familiar. It's not some massively new interface that you have to deal with. If your folks are familiar with running in a vSphere environment and they're comfortable operating in vCenter, if you have tooling and scripting and those types of things built against vSphere, it will continue to work with VMware Cloud on AWS. This cloud service is running vSphere. It's not running some special emulation or anything like that. It's ESXi on bare metal with vSAN, with NSX, running vSphere delivered to you as a service. So I mentioned the i3 instances. One of the things that we announced at VMworld this year is that we have put the R5 metal instances into preview. So this changes things a little bit. The i3 instances, they were the 36-core 72 vCPU, but they had the local NVMe instance storage. Is about 10 terabytes of local storage per host. Also with vSAN, though, keep in mind you can change that depending on how much fault tolerance you want to have. With the R5 instances, these are a little bit beefier boxes. So these are 48 cores, 96 vCPUs, 768 gigs of RAM. But these are using EBS for storage, for backend storage. So vSAN is actually leveraging EBS volumes to still create that dynamic data store. So it still scales linearly with compute. If you add an additional host, you get additional compute with that. But in this case, you can choose between 10, you can go beyond 10 terabytes of storage per host. So in this case, if I wanted to have 35 terabytes of storage per host, I could do that. So I could have 3 hosts in an environment, each with 35 terabytes, as opposed to having to scale out the i3 instances to be 9 or 10 hosts to get the same amount of storage. This is really important from a DR perspective. If you're considering DR with VMware Cloud on AWS, this gives you a really cool capability to just have a minimum of three hosts running in an environment, but still have 90 terabytes of storage. And then if you need to actually execute on a DR event and scale up, you can then click the button or make the API call and then add hosts to the cluster when you have a DR event, and then scale it down when you no longer actually need that capacity. So 2 instance types are the big key takeaway here. You have the i3 metal and now the R5 metal, which is in tech preview today. And we'll be able to talk more about those as we go through the vSAN piece as well. I talked about on the networking side that you don't actually see the VMs sitting in your VPC. I want to just set the stage a little bit or provide some basic fundamental information about how VMware Cloud and AWS works. Anybody in here used RDS before? Yes? Okay, good. So when when you actually provision RDS, you click, I want the database, and I want to have it connected to this network, and you see an ENI pop up on that network, on that subnet, and that's how you get connectivity into that RDS database. But you never actually see the compute resources. You don't see a new EC2 instance pop up that's running that database. VMware Cloud and AWS is very similar. When I click to deploy a new VMware Cloud and AWS environment, I don't see EC2 instances pop up in my account. What's happening behind the scenes is VMware actually creates a dedicated AWS account just for you, so it's a single tenant solution, and they deploy all of the VMware Cloud and AWS resources into that account. They will then connect this account back over to an AWS account that you specify at the time of provisioning. So there's 2 bills, there's 2 accounts here. One, VMware is going to run all your resources needed for VMware Cloud, and they're going to bill you for the VMware Cloud service, but you don't actually see the actual resources running in your account. If you want to leverage native AWS services, so say, for example, that RDS database, you want to have a VMware Cloud and AWS VM connected to an RDS database in your AWS account, you can do that, and that would all be within your native AWS account. So key takeaways here, this is a single tenant solution. This is not some giant mass of a vSphere environment that's multi-tenanted. For every customer, VMware creates a brand new AWS account. They're actually using AWS organizations to do that, so they create a child organization account for that. They deploy all the resources in there, and they deliver that to you as a service. You have your AWS account, which you use for your native AWS services.
With Andy setting the stage for us, talking about the kind of bare metal instance available, talking about the account setup, and talking about the entire technology stack here, we now look at this picture where it's a truly hybrid illustration. It has, a little bit of a both world. On the left-hand side is the customer data center that we're all familiar with, right? These are data centers sitting on our premises, and we've been working with these equipment, bring them in, patching them, keeping them updated, serving business needs. On the right-hand side is AWS Cloud, and now we have VMware Cloud running on AWS as shown in the middle. It's been very common for customers to ask a couple of things in this setup, right? Number one, they said, I want this to be fast because moving into cloud transformation has been time consuming for us. Because it's the identical stack, as Andy talked about earlier on, this allows us to go through super fast migration because it is the same stack, right? For example, we have a customer, later on you will see them, one of our early adopters, Brinks, who drives the big security trucks around in many North America cities. They transferred or migrated over 300 VMs over a weekend. And this is using the HCX migration capacity, focusing on bulk migration. And the even better news is since then, because of the large adoption and the value confirmation from customers, we've now made HCX free. So the technology identical stack has really made it possible to go fast. Customer also say, not only I want coming into cloud fast, especially when I needed, to get out of a data center, my lease is upcoming for a renew, and I don't have the time to go through the refactoring or the rewrite of the applications. I also want to be able to access all of your great AWS services. This is really why I'm here at reInvent, right? And this gives us precisely that same capacity because VMware Cloud on AWS runs on AWS. As you heard early on when we talked about the redundancy, the host, the elasticity, right, the agility, all of these are cloud characteristics that you now get to benefit by using VMware Cloud on AWS. I also want to point out that on the left here, right, between VMware running on premises versus VMware Cloud on AWS, you get to transfer data pretty smoothly back and forth, as we early on talked about, right, for migration. Or many of you, if you're already familiar with vMotion, vMotion is supported with VMware Cloud on AWS just the same way. Right? You really don't have to worry about changes in there. Now, on this particular slide, though, I do want to highlight two little arrows. They may look insignificant, but they're a kind of most important part based on the customer feedback we've been getting. The first one I want to call your attention is at top left, right? And that is an arrow pointing between the management vCenter server that's on your on-prem data center to VMware Cloud on AWS, and it's bidirectional. Can somebody take a guess? What does that little arrow represent here? Say that louder, please.
Hybrid linked mode, yep.
Hybrid linked mode, thank you very much. So hybrid linked mode allow customers using the same vCenter interface to see your resources both in on-prem data center as well as in VMware Cloud on AWS. And this we've been repeatedly asked for, right? Give me a single pane of glass. Here you go, right? So that's definitely happening there. I also want to call your attention to the arrow that's lower down there, the yellow color that's connecting between VMware Cloud on AWS and the rest of the AWS services. Know that when we put VMware Cloud on AWS there, we do not want to ask customers to worry about setting up all the proper tunnels in order to go access AWS services. So if you remember earlier on in the slide where Andy talked about setting up 2 accounts, right? The VMware Cloud on AWS account and your own AWS account. By getting these 2 accounts associated here, we leverage both NSX and ENI here to give you the ability to extend into rest of the AWS services. So this is high bandwidth, low latency, not much extra work that you have to worry about by being aware of the 2 separate accounts, one operated, supported by VMware, the other one your own AWS account, but both exist inside AWS environment. Now, with this core architecture in mind, I've been getting a lot of inquiries from customers to say, but what kind of use cases, like when do I use this for, right? As I mentioned, we've learned quite a bit from our customers about the type of use case and the type of business you guys run every day that make it possible to leverage the benefit of this particular product. So here I'm highlighting 4 use cases. The very first one are those who needs to have a cloud transformation as their company key objective. So we call them cloud migrations, right? Now the cloud migrations can either be application specific, data center wide. You have a lease coming up, you wish not to renew it anymore. You have a physical location that you're doing a massive amount of changes there, so therefore it's easier to have them to be up on the cloud. You wanted to switch your cost structure from the traditional CapEx to more of an OpEx-based structure, at least for the portion of the workload. All of these happens. We also had conversation with folks where to say, hey, if you're dealing with a merge and acquisition, if you're bringing in a company, right, rather than inheriting and maintaining that foreign remote site at a different location, sending staff there and making sure everything there is up and ready, a pretty easy way is to have that migrated up to the cloud, and you can easily manage that from wherever you are. And in fact, by using VMware Cloud on AWS, majority of that heavy lifting, at least the patching, the updating, is handled by the solution itself, right, as part of the solution offering. So that's kind of where cloud migration comes in handy. I do have a customer in UK, Stagecoach. They have about 40,000 employees, and they have tons of applications. And these applications handle and keep track of their scheduling, they do route management for their 8,000 buses. And they also require very frequent update, as you can imagine, right? Every 30 seconds or so, they have to go through the updates so that precisely any given point of time, where is the bus and what's the schedule impact together with the local traffic condition. So as a result of that, they picked VMware Cloud on AWS for a couple of reasons, right? Number one, it was super fast to lift and shift and transform their applications into VMware Cloud on AWS. Number two, they now have ability to extend into additional AWS services. And one thing they also, in particular, was looking for was high availability, right? They needed this to be highly available because of the operation principle there. And therefore, they actually used a feature later on that I will talk about, which is the stretch cluster across not only stretch clusters, but also now across multiple AWS AZs, availability zones there. So that's a super cool alignment based on what they need versus what we can provide. The second use case that's also common, right? If you say a lot of customers, including some of those that I've been meeting in the last couple of days, to say, I'm not quite ready to just completely go without my on-prem data center, but I am interested in hybrid. Because, couple of things. Number one, if I do some dev test, I'd rather not to have any of those work impact my production server. Makes sense, right? Not impact my customer experience. So I want these to go somewhere else. And this is when you have dev test workload, burst out to the cloud is a very ideal situation. And I was also suggested to say there's also situations where our workload can be seasonal. Right? I was talking to a learning company earlier today where they shared, their users tends to drive a higher level workload Sunday night, probably because the project is due Monday morning, versus Friday night, they don't see much traffic and usage in their applications. So when you have these kind of clear usage pattern and traffic pattern, you can leverage such hybrid kind of a setup here so that the peak runs can go right into the VMware Cloud on AWS. The core run continues for your VMware running on-prem. But the key thing there is you no longer have to have these extra capacities sitting in your on-prem data center, but only being utilized at a marginal ratio due to the nature of the workload, right? So economic-wise, it's going to make much better sense there. And one thing I love about hybrid, which is the data center extension use case here, is you extend, which means you provision, and then when you're done, you bring it right back. Right later on, we'll show you some of that through the demo. And with that level of flexibility, you can go back and forth, and you never lose the visibility. As we talked about earlier on that one little arrow for vCenter, you get to see it in both worlds, and you get to also use vMotion, for example, transfer the workload back and forth should you ever have a need. So it's not just one directional there. So that's the second use case there related to data center. Now we'll go to the third one. The most popular one is disaster recovery. So I listed an example here, PHH Mortgage. They're one of the largest lending companies in the world, right? And they've had significant amount of workload that they've been spending money for DR purpose, because these are loan documents. Important to have them ready and not to have any unexpected situation. So the way they looked into this is not only they can do massive amount of migration, but from a DR perspective, leveraging what they're already previously familiar with for SRM, they can now drive much better economic ratio there. In fact, in addition to PHH, we've had a lot of other customers trying out the disaster recovery use case. And I've invited a particular customer here to share with us their very recent journey and story. So I'm going to have Jason come up from Lansing. Jason, tell us a little bit about yourself and your company, and tell us about your DR experience.
Thanks, Jen. Yeah, Jason Sears, Lansing Trade Group. And as Jen mentioned, we started off looking for disaster recovery solutions. We discovered the VMware Cloud option here about 2 months ago, and we were living in a colo facility, standard backup procedures, off-siting. We were missing the target environment that we needed to restore to. So ultimately, the VMware Cloud environment was something that we kind of looked at a little bit skeptically initially. I was concerned that it wasn't going to live up to all the hype, but long story short, fortunately, it met all our needs. I was able to, probably at about a weekend, in an afternoon we got configured with the hybrid cloud extension, and then over the course of a weekend we were able to validate, synchronize, and actually do some testing with it. We ran through a number of scenarios over the course of the next month, validating different scenarios, confirming everything was working for us, and after about a month of ensuring that this system is going to meet our needs, we actually flipped the roles to where our on-premise system is now our disaster recovery, and we're running primarily out of our cloud environment. So that gives us 100% cloud primary role environment, and then ultimately, if we have an event, we can fail back to our systems that are on-premise. Now, that's just an initial step. We're eventually going to look at other options to completely decommission our on-premise environment, but this was definitely the first step in getting us through that initial hurdle of meeting our disaster recovery needs. Some of the performance improvements we've seen, I've had a number of, we did this without obviously our users really seeing any impact, and then through the course of running on it after a couple weeks, we started to see our load times, our data processing times, things that we do on our batch processes were significantly improved. Our users experienced much quicker response times from the applications that we had running up there. So in the end, it just turned out to be a much better solution than we had initially envisioned, just serving in our disaster recovery roles.
Thank you so much, Jason. I really appreciate that. As Jason talked about, right, an afternoon to get HCX to set up, then it's probably a Friday afternoon, right? Then run the migration over the weekend. with no user impact because there's no downtime during the migration, right? And then from there, recognizing the significant savings from the TCO perspective. These are really some of the key design points we want to hit. One side, we want to give you the comfort and know that you're operating in the same technology stack, but at the same time, we also want to give you the best of the both world, right? Meaning besides the VMware side, also give you some of the key features as we've talked about in the AWS side. Now, what's also interesting is after many customers experimenting with use cases such as cloud migration, data center extension, or DR, as Jason has just mentioned there, they also get started to look into the next generation of applications, right? They started to do new application development. They started to venture out to focus on application modernization. You saw that I have Brinks listed here as one of the earlier security truck examples. I also have a couple of customers from Hill Air Base Force here, they've been super brilliant in the sense that they leverage VMware Cloud on AWS to help them significantly improve the onboarding time of their customers, right? Because they were able to leverage the virtualized environment. Now, we have packed materials for this deep dive session. Therefore, what we're going to do is at the end of it, rather than doing broad Q&A, we're just going to have these customers stay around, help us here to address any of your questions, right? We figured having, talking to them directly, in addition to talking to us, may be interest for you. So if that's the case, just, come up and see us. I'm going to try to pick up the pace a little bit, right? So far, in about a year, you'll see that we've gained quite a bit of a customer momentum. We really have customers in every vertical, every segment, including, not just the commercial sectors, but even our public sector customers, as I mentioned earlier on from Hill here. And certainly, we've been doubling our customer counts every quarter. But how do we do that, right? Back to the deep dive session here, I think it's important to highlight, now that we have a mission to offer customer things that's easy, fast, economically attractive, we know we have to go through some deep joint engineering work. And these are sort of the 5 areas that Andy and I chose to highlight for you guys a little bit more for the rest of our journey. And we'll follow these with the demo. These 5 things we will be talking about includes not only the networking side, such as Direct Connect, or the security side, or the account integration, but also related to some of the storage flexibilities that we've hinted on earlier, right? I'd love to share a little bit more, as well as high availability, which is super important for, I'm pretty sure everybody here, running these VMware workload traditionally in the on-prem environment. So Andy, I'm going to hand this over and have you cover some of these highlights for us.
Great. Thanks. Okay, let's start off with talking about the connectivity piece. This is one of the most important parts about VMware Cloud and AWS. Most folks who are looking at VMware Cloud and AWS are not looking at using it in a vacuum, right? They're looking at either migrating into it from their on-prem environment, they're looking at connecting it to their native AWS services. So connectivity is a big part of this. Whenever we initially launched the service, we were using NSXV. So that was the initial NSX vSphere-based version. We've since transitioned over to NSXT. That transition is happening right now. With NSXT, we've actually introduced some features and functionality that customers have been asking us about. So first and foremost, I want to talk about the connectivity from a compute gateway and a management gateway. So if you've read or learned anything about VMware Cloud and AWS before, you know that there's not a separate management cluster for this environment. So VMware is basically leveraging resource pools, and they're leveraging NSX to logically segment off the management infrastructure. So there is no separate management cluster like you would typically see in an on-prem environment. So in this case, we have a compute gateway, which that's going to be the edge services gateway, the NSX edge that is sitting in front of all of your compute workloads. Behind that NSX edge, that compute gateway, you can actually create many logical networks. So think of logical networks as equivalent to a VPC subnet. So in this case, I may want to have a logical network for my web servers or my app servers, but I can create multiple logical networks just in the same way on the AWS side I would create subnets. Distributed firewalling has been introduced with NSXT Now, distributed firewalling, you can think of it as being analogous to security groups. Or this is often called microsegmentation as an industry term, but this is ultimately the ability to segment two VMs from each other that are sitting on the same subnet, on the same logical network. So if you think about in a traditional environment, you would always create VLANs, and you would say, okay, this VLAN is going to be connected to this firewall interface, or you do sub-interfaces off your firewall, and that was really your inspection point. That was the piece that you used to filter traffic. But if a machine were compromised on that network, there was nothing really to stop that lateral movement. If they compromised web server 1, there was nothing really preventing them from getting to web server 2 and 3 and 4 and really moving horizontally. So microsegmentation or distributed firewalling really gives you the ability to segment traffic or to apply firewall rules at a vNIC level inside of VMware. So very similar to security groups, I can take this VM, for example, running on network A. So that's I have my logical network A. I have a database and an app server, both sitting on that same logical network. I can actually allow only specific ports between those two VMs sitting on that same network. So you can see the firewalling is done at a vNIC level on each one of those VMs, very similar to security groups. So I have the ability to create multiple logical networks. I have the ability to do distributed firewalling. The management gateway is the gateway piece for the management infrastructure. So your VCSA, your NSX control cluster, NSX manager, all of those things are sitting in a separate logical network that also have a completely separate gateway. One of the challenges that we kept hearing from customers is they would say, look, that's great. I love the fact that this is segmented out, but now I have to build twice the number of VPN tunnels. If I want my on-prem environment to be able to connect to my vCenter server, I have to build a VPN tunnel to my management gateway. If I want to connect to the compute resources, I have to build a VPN tunnel to my compute gateway. So now I'm managing multiple tunnels. And if I have resources running inside of my compute logical networks, I have no way for them to connect to anything behind my management network. Again, they're two separate gateways. So VMware took that feedback and they actually, when they went into NSXT, they created a T0 router. So in NSXT, they have the concept of tier 0, tier 1 routers. So in this case, they put a T0 router that is now sitting in front of each one of these gateway devices. So this provides a central point where you can actually terminate VPN tunnels and only have one set of tunnels and have access to both the management and the compute resources. So it streamlines the number of tunnels that you actually have to deal with in your environment. This also provides connectivity from the native AWS VPC as well as the compute resources into the management network. So from your compute resources, a common use case we were running into is folks had virtual appliances or tools that they were using to actually monitor or connect and perform tasks, automation, for example, on the vSphere API, but they didn't have access from their compute environment. So now that's been solved. This new T0 router is in place, and that provides that connectivity. So a little bit of a change in the infrastructure and the architecture from what we talked about last year or what you may have heard about in the past. Another cool thing with this introduction of the T0 router and being able to do the consolidated VPN tunnels is they now support route-based VPN as opposed to just policy-based VPN. So for those who are wanting to run BGP and do dynamic routing for the VPNs, you can now do that as well. So that functionality has been added as well. We also have done some work around direct connect. So a common thing we were hearing from customers is I want to leverage my AWS Direct Connect. I have this Direct Connect circuit in place. I've been paying for it and using it to connect to my AWS environment. I'm interested in using VMware Cloud and AWS, but I want to be able to leverage Direct Connect for that as well. When we initially launched, we were able to leverage Direct Connect for the management infrastructure, but we were not able to actually get into those overlay networks. So if you've done much with Direct Connect or even multiple accounts, you've probably run into an issue around transiting through AWS accounts and not being able to do transitive routing, as it's often called. In this case, we worked with VMware and we were actually able to take that Direct Connect traffic and be able to route that into the overlay networks directly. So what this allows you to do is from your on-prem environment, across a Direct Connect, you can access these vSphere logical networks directly. So if you're using Direct Connect, you do not have to build a VPN tunnel to be able to access those resources. And that's something we were hearing quite a bit about as people said, hey, I have this Direct Connect, it's a 10 gig circuit, but I have to build a VPN tunnel across that Direct Connect to access these overlay networks. In my firewall, to be able to achieve 10 gig, I'd have to replace that hardware. It's not common to be able to do 10 gig on a firewall without buying some pretty expensive iron. So that feedback was taken in and we were able to develop this feature to allow Direct Connect direct access into these overlay networks. So if you have Direct Connect today or you're using that with AWS, just know that you can now leverage that same Direct Connect circuit. You can drop a private hosted VIF into that account I mentioned earlier, the SDDC account, and that will be able to provide access into these VMware overlay networks. So really clean, seamless access between your on-prem environment and your VMware Cloud and AWS networks.
And I would also add a couple of additional features that customers has been asking quite a bit that we've took us some effort, between two companies working very closely, then roll it out. One of them is high availability. Right? High availability, I know, is a very big deal for any enterprise workload. We have critical customer needs to serve here. And therefore, the high availability zero RPO has been a very common notion in the VMware users world. Now we add additional guarantee on top of that, which is we've now allowed this to happen across AWS multiple availability zones. So if you look at the illustration here, right, initially we've always had the NXX, logical network, but as it stretch, going through the stretch clusters, it can now go across availability zone A versus zone B, as I've done in the illustration here. But even, the best yet, all of these changes, you don't have to make application change or code change in order to say, I need to leverage this feature, right? This is simply there. There's no need to re-architect of anything. And when you have, let's say, something happen in one availability zone, and basically this failure will be treated as a HA event, and the VMware Cloud on AWS will be able to reroute the traffic from the failure AZ over to the other AZ, and your work continues, right? User is not getting impacted. So that high availability is now super important if you think about from a global customer perspective, not only in where you're being set up, but possibly allow you to do a much broader sense in global scale here.
Yeah, if you think about when we started off the conversation, we were talking about those workloads, those virtual appliances or legacy workloads that maybe they didn't take well to IP changes and things like that. So the stretch cluster really solves that problem, right? You can take a workload that can't be re-IP'd or that doesn't take well to running horizontally, and you can actually have it stretched across multiple availabilities or run on a cluster that's stretched across multiple availability zones without having to make it cloud aware, AZ aware, anything like that. So no changes to the logical constructs or no changes to the applications, but it's able to take advantage of these cloud constructs. This is a feature that a lot of folks are really excited about because there apparently are a lot of these legacy workloads or a lot of applications out there that just were not designed to take advantage of multiple AZs or to be able to be re-IP'd quite easily.
Obviously. And then with that, of course, I also have other customers to say, wait a minute, right? You've talked about great things such as networking, such as high availability, but my application has some pretty significant storage characteristic. Aren't you guys doing something about storage, right? The answer is, of course. I think when we initially looked into VMware Cloud on AWS, we looked for the balanced starting point of, for workloads that has similar amount of compute and storage need. But we do know that doesn't cover all of the use cases, right? So for example, if you, as we talked about early on for DR, obviously, that's very storage heavy. If we talk about, people in gaming, let's say, then their compute could be fairly extensive. But if we have customers who have significant amount of data and their data is, increasing at a pretty significant pace, and they needed to keep all of those data stored nicely there, they don't really want it to have to buy compute or increase the number of the hosts, as Andy has discussed earlier, every time. So for that reason, we've brought in this new capability of R5, as you recall earlier on, right? So besides i3 bare metal, we now also have R5. And one key characteristic for R5 is, for R5 situation there, the storage option is the vSAN backed by EBS. And what that really means is it gives you a much better price performance ratio if you happen to be one of these storage heavy workload, right? You will get to increase your storage per host range there from 15 to 35 terabyte, and you don't have to go all the way there. You can increment them in 5 terabyte each time. And more importantly, when as you operate this way, what initially happened is you would start with your i3 cluster being your initial SDDC there for your very first cluster. And then from there, you can add these additional R5 as new clusters to address your specific storage need, right? So all of a sudden, your blueprint is becoming much richer with additional flexibility and options, depends on the type of the workload and the characteristic of your workload there.
So what we're going to do is we're going to kick over to our demo real quick, just to make sure we have time to go through this. And if I push the right button.
You did.
All right, so I want to start off by just showing you what the VMware Cloud with AWS interface looks like. So if you haven't logged into VMware Cloud with AWS, this is the main interface. I know I mentioned earlier you log into vCenter, and just to be clear, this is not a replacement interface for vCenter. This is an environment where you can go in to create these software-defined data center constructs that we talked about. So here I have 2 software-defined data centers. You can see I have this IAD demo cluster. If you notice under actions, some kind of interesting things here, I can click a button and add a cluster. So as Jen was just mentioning, if I wanted to add an R5 cluster, I could come in here, click add cluster, and I could have multiple clusters running in my environment. So I can scale each individual cluster from 3 nodes all the way up to 32 nodes, but I have the ability to add up to 10 clusters in an environment. So think about the amount of scale you can achieve with this. 32 hosts per cluster, all the way up to 10 clusters in a SDDC. That's a pretty significant environment that you can spin up. I can also add hosts and remove hosts. Again, we talked earlier about the elasticity, the ability to scale. So that's literally just a click of a button in the console, or actually through the API. If I were to jump into the SDDC, I can see this environment that I'm looking at is a 4-host environment. It shows me kind of the information about that environment. And then I just have the button that says Open vCenter. So if I want to jump right in as a vSphere administrator and start working in my environment, I just click Open vCenter, and I can log in there. Some kind of interesting things here. I do want to point out, VMware is continually releasing additional extensions or add-ons into the VMware Cloud service. Some of them are free, some of them have costs involved. I would definitely recommend checking out the Hybrid Cloud Extension, or HCX, if you hear that mentioned. If you're looking to do a cloud migration, which is something we hear a ton about, HCX is a free solution. So it's not, if you're migrating into VMware Cloud and AWS, there's no charge for it. And this is amazing. It extends your layer 2 networks. It'll help you do orchestration. I cannot stress enough, if you're looking at using VMware Cloud as a destination target for a cloud migration, please, please, please take a look at HCX. The feedback we get from customers is pretty amazing and has a great setup there, so take a look at that. All right, so if I were to click the Open vCenter button, I'm going to jump in here. Notice on the left-hand side, I have 2 environments. I have a VMC Lab and the vCenter SDDC. So we talked about hybrid linked mode earlier. So hybrid linked mode gives you that single pane of glass, the one interface. So here I have an on-prem data center, which is VMC Lab, and I also have my software-defined data center, which is the cloud environment. So what we're going to do in this case is we're actually going to go in and we're going to find our resource, and we're going to move it from the on-prem environment into the cloud environment. So if I picked the right folder, I can see I have a web server, and I'm going to right-click just as I would in an on-prem environment. I'm going to do migrate. I'm going to go through and do the enhanced vMotion or the XVMotion functionality. So I'm going to move both compute and storage. I'm going to pick my SDDC as the destination. I have cluster 1. Remember earlier I mentioned we're separating out by compute management resources. So here I can see the resource pools. I'm going to put this in the compute. If I were to try to click on management, I would not have permission to do that. That is restricted. So I'll click my compute resource pool. Also the same thing on vSAN. Traditionally in an on-prem environment with vSAN, you don't have the ability to create multiple data stores. In this case, VMware has created a management data store and a compute data store. So again, kind of the same story there. I'm going to click on the workload environment. And then I'm just going to pick a folder to move this into. And I'll pick a network. Now, I did, just for the sake of this demo, I am not stretching a network. So you can see here I have 3 networks that are actually stretched. If I wanted to extend those networks and not have to re-IP the VM, I could pick a stretched network. In this case, I'm just going to throw it in a public network. It'll do the validation check. And I'm going to schedule this at high priority because I'm special. And does anybody ever not pick high priority? Just curious. I don't even it's like a button saying I would like to go slower. I'm sure that people actually do use it. So if you notice down at the bottom, the vMotion is kicking off and it's actually running. So we're actually moving a VM live while it's running from an on-prem environment into our VMware Cloud and AWS environment. So this is using the hybrid linked mode approach. A couple things to point out: you do not need NSX on-prem to be able to do the stretch networking. So HCX has built-in stretch networking. VMware also has a virtual appliance that they've released that allows you to do an L2 extension between your on-prem environment and VMware Cloud and AWS. So I get asked this question a lot: do I need NSX to run or to take advantage of the capabilities of VMware Cloud and AWS? The answer is no. You can do that with either HCX or this L2 extension, or even just traditional IPsec VPN connections. So in the time it took me to say that, the VM is actually no longer running in VMC Lab. If I go extend my data center once and look under my workloads, I can see that the VM is now actually running in my CMP305 folder. So we talked about that connectivity between your VMware Cloud and AWS account and your native AWS account. And this is the thing that it's really important. So if you're doing a migration, I would just encourage you, don't just migrate your workloads and lift and shift into VMware Cloud and AWS. Take that extra step and look for applications that can take advantage of the native AWS services. There's a lot of services available. We hear people talk a lot about using S3 or leveraging RDS or even networking services. So in this case, I'll give you an example. I have this web server, and if I were to go click on this web server and just try to hit it directly, I have the greatest web page ever created. It is extremely detailed. So this is the actual IP address of the VM we just moved. So I can see that machine is 172.1.1.100. So I'm going to jump over and into my AWS console. And we announced a feature last year on the AWS side that allows you to actually target IP addresses behind an application load balancer. So if you've ever used ELB or ALB in the past, traditionally you would say, okay, here's my load balancer, I want to define a server pool, and here's the EC2 instances that I want to use, and you just specified the instance itself. But what if you want to leverage this VM that I just moved? What if I want to put it behind an AWS load balancer? In this case, we have this feature called target groups, IP-based target groups. So you can see right here, I have the IP address of the VM defined in this target group. And if I were to jump over into my load balancer and actually look, I can say I want to have a listener of that target group. So now I have my VMware Cloud and AWS VM sitting in an IP target group on my AWS config. And if I were to go back and actually just grab the load balancer URL and drop that in there, I can see that I've now had that VM behind. Well, our application load balancer actually also has other capabilities. It integrates with AWS WAF. So if I were to jump over and actually look at our WAF and Shield config options, I have an option here to, if I were to look at the rules, I could do things like URI filtering if I want to block /admin on this website. So in this case, if I actually click on it so you can see, if the URI has /admin in it, I'm going to go ahead and block that on the WAF. So jump back over to my ALB page. So grab that. So there's my base page. If I do /admin, it's blocked. So this is a case where we literally, while we were all sitting here in the room together, we took a VM from an on-prem environment, we live vMotioned it into VMware Cloud and AWS, and then we just configured a target group and pointed that target group at the IP, enabled WAF, and have WAF actually protecting that workload. So really good example of just how you can extend these applications and have them leverage native AWS services. We're bumping up on time, so we're gonna cut through the last couple of items. But we initially launched the service in a few regions. We had US West, US East, London, Frankfurt, Sydney. We were launching one region at a time. We've actually, VMware has really been working closely with AWS, and we're working to accelerate the launch. So keep an eye out if there's a region that you have a particular interest in. We're working on getting those regions up and running and going as quickly as possible. We're actually announcing 5 additional regions here in the fourth quarter. But our goal is to have all AWS regions functional with VMware Cloud and AWS by the end of next year. So keep an eye out if there's a particular region you're interested in. We already dropped through the demo.
And I think, from here, many folks would say, this is so cool, Andy, to see what you showed us. What if we also want to get our hands on it, right? Obviously, hands-on lab, as we mentioned here. Many of you probably already have read from our press releases. We now have a starter configuration. That's a one-node SDDC. Swipe your credit card and go play with it.
The thing on the OneNode is the OneNodes are time-bound for 30 days. So if you want to just try this out, the OneNodes is just a single host. If it fails, the data is going to be gone on it, but it gives you an opportunity to try it out for 30 days. The use cases Jen mentioned earlier, if you think about a use case that's applicable to you, you can leverage the OneNode and actually validate that use case is functional in your environment.
I think the benefit there is, one, you get to try with one of your real use case in-house, and two is from there, if you're ready to put this into production, it's one button click right there. In fact, one thing we'll mention is we also now have the 3-host SDDC that's currently having a promotion going on as well. So Andy, why don't we pause here with the very last picture showing some of the additional sessions and content. If folks want to take a picture here, rest of the week you can continue to explore about this product. And of course, feel free to come up or we can hang out and answer any of your questions.
Yeah, so lastly, we really appreciate you guys taking the time to come in and chat and listen to us today and interact with us. We'll be around for questions, as Jen mentioned. It would be greatly appreciated if you guys could fill out the survey. Let us know what you liked. Let us know what we could do better. We want these sessions to be beneficial for you, and we would greatly appreciate your feedback. Thank you for taking the time to join us today. Have a great day.
Thank you.